This video is about sinusoidal modeling. In other words, modeling a given situation using sine or cosine. This is AP Precalculus topic 3.7. If you appreciate this content, please give it a like. Number 1. The figure shows the graph of a sinusoidal function f. What are the values of the period and the amplitude of f? First, draw the midline, which is halfway between the highs and the lows. The first period of f starts at 0 and ends at 6, so the period is 6. The amplitude is the distance between the middle value and the maximum value. 5 minus 1 is 4, so the amplitude is 4. This corresponds to an answer of C. Number 2. The figure shows the graph of a sinusoidal function h. What are the values of the period and the amplitude of h? Well, one period of this function starts at 0 and ends at 4. Therefore, the period is 4. The amplitude is the distance between the midline and the maximum value. In this case, we see that the amplitude is 3. This corresponds to an answer of C. Number 3. The figure shows the graph of a sinusoidal function k. What are the values of the period and the amplitude of k? One period of this function starts at 0 and ends at pi. So the period is pi. The amplitude is the distance between the midline and the maximum value. In this case, the amplitude is 2. This corresponds to an answer of C. I'm starting to wonder if all the answers are going to be C. Number 4. The figure shows the graph of a trigonometric function f. Which of the following could be an expression for f of x? Let's consider each option one at a time. The full model for a cosine function looks like this, where we would expect to see a c value in this position, the opposite of which is the phase shift. However, option A has no c value. In other words, there is no phase shift. That means that the first period of this function will begin right at 0. We have memorized that the parent function cosine x looks like this. Since function a is a cosine function with a positive a value, then the first period should look just like this. However, the first period of f looks like an upside down version of this. This would happen with a negative a value. But since option A has a positive a value, it should have been a right side up cosine, not an upside down. So the answer cannot be A. Function B is another cosine function with a positive a value. So the first period should be a right side up cosine function which looks like this. Function B has a c value of negative pi over 2. That means the phase shift is positive pi over 2, the opposite of this. That means the first period will begin right here at positive pi over 2. However, if I trace one period of the graph of f starting at positive pi over 2, it looks like this. This is a positive sine function, not a cosine function. So B cannot be the answer. Function C is a sine function with a positive a value. So the first period should look just like the parent function. It should look just like this. The c value is negative 3 pi over 2. Therefore, the phase shift will be positive 3 pi over 2. That means that the first period of function c will begin right here at positive 3 pi over 2. However, if I trace out this first period starting at 3 pi over 2, we get an upside down sine function, not a right side up sine function. So C cannot be the answer. By the process of elimination, we know that D must be the answer, but let's follow through and see why. Function D is another right side up sine function because it's a sine function with a positive a value. Function d has a c value of negative 5 pi over 2. That means the phase shift is positive 5 pi over 2, which means the first period of function d will begin right here. If we go ahead and trace out one period of the graph of f, it's going to look just like this. This is a match for a right side up sine function, confirming that the answer is D. Number 5. The figure shows the graph of a trigonometric function g. Which of the following could be an expression for g of x? Function a is a right side up cosine function. It's a cosine with a positive a value, so the first period should look like this. The c value is negative pi over 2. Therefore, the phase shift is positive pi over 2. That means the first period of function a should start right here at positive pi over 2. However, if I trace out a period starting at positive pi over 2, I get an upside down cosine function, not a right side up cosine. So a cannot be the answer. Function b is another right side up cosine function with a positive a value. So the first period should look like this. This time the c value is positive pi over 2. Therefore, the phase shift is negative pi over 2. That means the first period of function b will start right here at negative pi over 2. If I trace out one period of graph g starting at negative pi over 2, we get this, which is a right side up cosine function just like we wanted. So this is probably the answer. I'm not going to say that b is the answer until I eliminate the other options. Function c is a right side up sine function, so the first period should look like this. Function c has a c value of negative pi over 2. Therefore, the phase shift is positive pi over 2. So the first period of function c should begin right here at pi over 2. If I trace out one period of the graph of g starting at 2 pi, I get an upside down sine function, not a right side up sine function, which would match option C. So option C cannot be the answer. Function d is an upside down sine function with a negative a value, so the first period should look like this. Function d has a c value of negative pi, so the phase shift is positive pi. Therefore, the first period of function d will start right here at pi. If I trace out one period of the graph of g starting at pi, I get this shape, a right side up sine function, not an upside down sine function like we were looking for. So option D cannot be the answer. We have now confirmed that the answer is B. Number 6. The figure shows the graph of a trigonometric function h. Which of the following could be an expression for h of x? With this negative a value, option A is an upside down cosine function, so the first period should look like this. The c value is positive pi, therefore the phase shift is negative pi. So one period of the graph of h should start right here at negative pi. However, if I trace out one period starting at negative pi, I get this upside down sine function shape, not an upside down cosine shape. So A cannot be the answer. With its negative a value, function b is another upside down cosine function, so the first period should look like this. The c value is negative 2 pi, therefore the phase shift is positive 2 pi. So one period of function b should start right here at positive 2 pi. However, if I trace out one period, it's going to look something like this. This is a right side up cosine function, not the upside down cosine function we were looking for. So option B is not the answer. With its positive a value, function C is a right side up sine function, so the first period should look like this. The c value is positive pi, therefore the phase shift is negative pi. So the first period of function c should begin right here at negative pi. However, if I trace out one period starting at negative pi, I get this shape, which is the shape of an upside down sine function, not the right side up sine function we are looking for. So option C is not the answer. By the process of elimination, we know that option D must be the answer, but let's run through it anyway. With its positive a value, we know that function D is a right side up sine function, so the first period should look like this. The c value is negative pi, therefore the phase shift is positive pi. So the first period of function D will begin right here at positive pi. And if I trace out one period starting at pi, I get a shape that looks like this. And guess what? This is the shape of a right side up sine function, which is exactly what we were looking for, confirming that option D is the answer. Number 7. The figure shows the graph of a trigonometric function k. Which of the following could be an expression for k of x? With its positive a value, function a is a right side up cosine function, so the first period should look like this. The c value is 0, therefore the phase shift is 0. Therefore, the first period of function a should start right here at 0. However, if I trace out one period starting at 0, I get this shape, which is an upside down cosine function, not a right side up cosine. So A is not the answer. With a negative a value, function B is an upside down cosine function, so the first period should look like this. Function B has a c value of negative pi, therefore a phase shift of positive pi. So the first period of function B should start right here at pi. If I trace out one period starting at pi, I get this shape, which is a right side up cosine function, not the upside down cosine we were looking for. So option B is not the answer. With a positive a value, function C is a right side up sine function, so the first period should look like this. Function C has a c value of positive pi over 2, therefore a phase shift of negative pi over 2. So the first period of function C should begin right here at negative pi over 2. However, if I trace out one period starting at negative pi over 2, it looks like this. An upside down sine function, not the right side up sine function we were looking for. So option C cannot be the answer. Option D has a negative a value, so we are looking for an upside down sine function. So the first period should look like this. The c value is negative 3 pi over 2. Therefore, the phase shift is positive 3 pi over 2. So the first period of function D should begin right here at positive 3 pi over 2. And indeed, when we trace out one period starting at 3 pi over 2, we get a shape that looks like this, an upside down sine function, which is exactly what we were looking for, confirming that the answer is D. Kabam! Number 8. The figure shows the graph of a trigonometric function p. Which of the following could be an expression for p of x? With a negative a value, function a is an upside down cosine function, so the first period should look like this. The c value is negative pi, so the phase shift is positive pi. Therefore, the first period of function a should start right here at pi. If we trace out one period starting at pi, we get a shape that looks like this. This is a right side up cosine function, not the upside down cosine we were looking for. So option A is not the answer. With this negative a value, function b is another upside down cosine function. So the first period should look like this. The c value is negative 2 pi. Therefore, the phase shift is positive 2 pi. So the first period of function b should begin right here at positive 2 pi. If we trace out one period of the graph starting at positive 2 pi, we do get a shape that looks like this, an upside down cosine function, just like we were looking for. So function b is probably the answer. Let's eliminate the other two options. Function c is a right side up sine function, so the first period should look like this. The c value is negative 3 pi over 2, so the phase shift is positive 3 pi over 2. And the first period should begin right here. But if we trace out one period starting at positive 3 pi over 2, we get this shape, which is an upside down sine function, not right side up. So not c. Function d is an upside down sine function, so the first period should look like this. The c value is negative pi over 2, therefore the phase shift is positive pi over 2. That means the first period should start right here at positive pi over 2. If we trace out one period starting at pi over 2, we get this shape, which is the shape of a right side up sine function, not an upside down sine function. So the answer is not D, thus confirming that B is the answer. Number 9. In a particular city, the amount of daylight hours is modeled by the function d, defined by d of t is equal to this expression. On the closed interval from 0 to 365 days, based on the model, which of the following is true? The d value indicates the value of the midline, so 12.250. I notice that there is no c value added or subtracted in here, so that means that the phase shift is 0. In other words, the period begins right here at 0. Option A, the maximum amount of daylight hours is 12.250 hours. Nope, 12.250 is the midline, the middle number of daylight hours, not the maximum. So A is not the answer. Option B, the maximum amount of daylight hours occurs at t equals 0 days. That is correct. I drew it as a positive cosine, a right side up cosine function, because we see that it is cosine with a positive a value. So we knew the shape would be like this. Once we took note of the c value being 0, the phase shift of 0, we knew that this period would begin right at 0. So yes, the maximum number of daylight hours occurs at 0 days. So the answer is B. Let's quickly run through the remaining options. The minimum amount of daylight hours is 12.250. Nope, that is the middle number of daylight hours, so option C is not the answer. The minimum amount of daylight hours occurs at t equals 0. Nope, the minimum occurs somewhere over here. The maximum number of daylight hours occurs at t equals 0. Number 10. For a given city, the average high temperature in degrees Celsius in a given month can be modeled by the function C, defined by this expression on the closed interval from 0 to 12 months. Based on the model, which of the following is true? I'm noticing that we have a cosine function with a positive a value. So I'm going to draw my sketch as a right side up cosine function. I also see that the c value is -1. Therefore, the phase shift is +1. That's why I am starting this period of the right side up cosine function at +1. Also, the d value is 14.1. Therefore, the middle value of this cosine function will be 14.1. So, option A, the maximum average high temperature is 14.1 degrees Celsius. Nope, that's the middle average high temperature. So the answer is not A. Option B, the maximum average high temperature occurs at T equals 0. Nope, the maximum temperature occurs at T equals 1. At T equals 0, it's going to be somewhat below that. So the answer is not B. Option C, the minimum average high temperature is 10.2. Well, the minimum temperature will be the middle value minus the amplitude. 14.1 minus 3.9 is 10.2. So the answer is C. The minimum average high temperature is 10.2 degrees Celsius. Glancing at option D, the minimum average high temperature occurs at T equals 1. Nope, that's going to be the max. Number 11. In Myrtle Beach, South Carolina, the height of the tide in feet is modeled by the function h, defined by h of t equals this expression, for the closed interval from 0 to 12 hours. Based on this model, which of the following is true? With a positive a value, this is a right side up sine function, so one period should look like this. Furthermore, I notice that we have a c value of -1, which means the phase shift is +1. So this period should begin right here at +1. We also notice that the d value is 2.6, so that's the middle value for the height of the tide. Option A says the maximum height of the tide is 4.7. Well, the maximum height should be the middle value plus the amplitude. And 2.6 plus 2.1 is 4.7. Kabam! The maximum height is 4.7. So the answer is A. Running through the wrong answers very quickly, option B says the maximum height of the tide occurred at T equals 1. Nope, that's when the middle value occurs. Option C, the minimum height of the tide is 2.6. Nope, that's the middle value. And option D, the minimum height of the tide occurs at T equals 1. No, again, that is the time where the middle value occurs. Number 12. The population of trout in a particular pond can be modeled by the function f, defined by f of t is equal to this expression, for the closed interval from 0 to 10 years. Based on the model, which of the following is true? First of all, understand that having this 3,000 in the front is the same as adding 3,000 on the end. So f of t could be rewritten like this, and this is more what we are used to. With this negative a value, f of t is an upside down cosine function like this. Also, we notice that there is no c value. The c value is 0. Therefore, the phase shift is 0, which is why I have drawn this period starting right at 0. Also, the d value is 3,000, so that is the middle value for the population of trout. Option A, the maximum number of trout is 3,000. Nope, that's the middle population of trout. So A is not the answer. Option B, the maximum number of trout occurs at t equals 0 years. Nope, at t equals 0 we have the minimum number of trout, not the maximum. Option C, the minimum number of trout is 1,200. Well, the minimum is going to be the middle value minus the amplitude of 1,200. 3,000 minus 1,200 is 1,800, not 1,200. So the answer is not C. The minimum number of trout occurs at t equals 0 years. Yep, that's what our graph predicts. So the answer is D. Hey guys, don't forget to like and subscribe.
But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.